Nobody knows me. 故意笑。Nobody knows my name.
85% of the universe is missing, invisible, untouchable, yet it holds everything together. Without it, galaxies would fly apart, stars would drift into the void, and we would never exist. This is the story of the universe's greatest ghost, dark matter. In the 1930s, astronomer Fritz Zwicky noticed something strange. Galaxies and clusters were moving too fast, so fast they should have flown apart. But they didn't. Something unseen was holding them together. He called it Dunkel Materie, dark matter. Decades later, Vera Rubin confirmed the mystery. Stars on the edges of galaxies orbited just as fast as those near the center, defying the laws of visible gravity. The universe, it seemed, was filled with hidden mass. Today, we know this invisible substance outweighs all stars, planets, and gas 5 to 1. It bends light, shapes galaxies, builds the cosmic web itself, and yet we've never seen it. From a God's eye view, the universe looks like a brain, vast filaments of galaxies connected by dark threads, an endless lattice of invisible scaffolding. Dark matter acts as the skeleton of creation. Every galaxy, including ours, sits in a vast halo of it. It is the silent architect that shaped everything we see, from the first stars to the rise of life itself. And yet, we still don't know what it is. For decades, physicists have hunted the shadow particle, the building block of this unseen world. Some call them WIMPs, weakly interacting massive particles. Others suspect actions or sterile neutrinos. The universe, they say, could be full of ghost-like particles passing through your body by the trillions every second, but so weakly we never feel them. Massive detectors buried beneath mountains wait in silence for a single collision. Years pass, no signal, only the hum of the void. Maybe dark matter doesn't interact at all. Maybe it obeys a different physics entirely. At the center of our galaxy, astronomers have found stars that shouldn't exist. They orbit perilously close to the supermassive black hole, where gas clouds are torn apart before new stars can form. Yet these stars shine young and bright. A radical idea has emerged. They could be feeding on dark matter. As they sail through dense clouds of invisible particles, collisions inside may release bursts of energy, a cosmic fountain of youth. If true, these dark stars could burn for trillions of years, immortal suns powered by the shadows. But what if dark matter is not just a particle? What if it has its own chemistry, its own atoms, forces, and even life? Some physicists suggest that dark matter could form complex structures just as ordinary atoms form molecules. Entire galaxies of dark stars and dark planets could be orbiting alongside us, completely invisible except through gravity. Could there be dark civilizations living in a parallel universe intertwined with ours? Perhaps they look up at their own night sky and wonder what unseen mass holds their worlds together, never knowing that we are the ghosts. The hunt continues. The Large Hadron Collider, deep underground neutrino labs, the James Webb Space Telescope mapping the faint glow of the early cosmos. Each whisper of light, each fluctuation brings us closer to unveiling the invisible. If we can discover what dark matter truly is, we'll unlock the fate of the universe itself. Because whatever dark matter is, it is the glue that holds reality together. Perhaps the truth is stranger than we can imagine. Perhaps the cosmos we see is only half the story, a bright reflection floating in an ocean of unseen worlds. Maybe the universe isn't dark at all. Maybe we are blind creatures of light, tracing the outlines of a much greater shadow. The more we learn about the universe, the more we realize it's what we can't see that defines everything we are.
Nobody knows me. Going south. Nobody knows my name.
This film continues where the Shadow Universe left off. We journeyed through the unseen architecture of reality, the invisible mass that anchors galaxies, sculpts the cosmic web, and quietly holds the universe together. For nearly a century, dark matter has remained a ghost, undetectable, untouchable, known only by the gravitational scars it leaves behind. But today, that may be changing. A new scientific study has revealed an unprecedented signal at the heart of our galaxy, a burst of high-energy light emerging exactly where dark matter is predicted to be most concentrated. In this short follow-up, we'll break down the discovery, explain what the data shows, and examine whether this could be humanity's first direct glimpse of the invisible. Is this truly light from dark matter itself, or just another cosmic illusion? Let's find out.
Nobody knows my name. Nobody knows my name.
Now, Professor Tomonori Totani of the University of Tokyo has uncovered something new. Using 15 years of continuous data from NASA's Fermi Gamma-ray Space Telescope, Totani identified a giant halo of high-energy gamma rays emerging from the precise region where dark matter should be most concentrated, the galactic center. Many physicists believe dark matter is made of WIMPs, weakly interacting massive particles, heavier than protons, invisible to light, passing through everything everywhere. But when two WIMPs collide, they annihilate, releasing gamma ray photons at specific energies. Totani found exactly those energies. Even more remarkable, this gamma ray halo is 10 times stronger than previous signals seen near the galactic center, and it extends much farther than expected. No known stars, pulsars, or black holes produce gamma rays this energetic. Dark matter may finally be revealing itself through the light of its own collisions. But not everyone agrees. Professor Joe Silk, a leading dark matter researcher, warns that the signal may be premature. He argues the glow could come from a 10 billion year old explosion. from the Milky Way's central black hole. That eruption created the enormous Fermi bubbles, massive structures stretching 25,000 light years above and below the galactic plane. The shock fronts from that ancient blast could accelerate particles, producing gamma rays that mimic dark matter. Totani agrees the evidence is not yet definitive. If dwarf galaxies, where dark matter dominates, show the same 20 GeV halo, it would strongly support the WIMP annihilation explanation. He remains confident future data will confirm it. If he's right, this would be the first direct detection of dark matter in history.
Nobody knows my name. Going shall